Hello everyone, welcome to the Stage Construction in S-Frame Enterprise webinar. My name is Alex, Structural Engineer at S-Frame Software in the UK, and I'll be leading this presentation today. In this presentation, you will learn how to evaluate the structure's behavior during and after construction, compare two similar but different models or structures in one interface, and how to easily and quickly code-check, design, and detail complete steel or concrete buildings, and more. To start things off, you may notice the Enterprise word in the title, and yes, this feature is only available in S-Frame Enterprise Edition. We will see the stage construction and some of its applications when working on stage construction projects. An example of a combined steel-concrete structure where we will be using S-Steel and integrated concrete design to perform the section design and comparison. Then, we will jump into the multi-scenario analysis and design, which is a second modality of the stage construction. And we will see an example of a steel frame using this modality. This is at the end of the presentation, but we will see how to create reports with each example we're going to show. Lastly, we will summarize the key points for this presentation before moving to the Q&A session. And these are the two modalities I was talking about: stage construction and multi-scenario analysis and design. Let's start with stage construction now. And why stage construction? It enables the structural engineers to get an accurate assessment of their design at each stage of construction. You can perform the structural analysis of your model, followed by a code check of steel or concrete components according to the major international standards. You can also evaluate the behavior during and after construction. And you can account for the preload conditions. Here's an example similar to the one we're going to work with. A regular framework conformed by 3 stories. We will define the geometry first, and then assign one stage per story, as you can see here. So we have stage 1, stage 2, and stage 3. And we will check on some of the results. Now let's move to the demo part of the presentation. Here's the model we described before. We will check the properties of this model, the load cases we define, and start defining our different stages. Let's take a look at the model properties in the geometry window. So if we take a look at the sections, we can see I have 2 sections defined, an IP 450 and a 450 by 450 concrete column. If we click this button here, the render model, we can better see our sections. So I have concrete columns and steel beams. We can right-click on this tool to better see the properties of these sections. We can see the IPE and the concrete column. Now moving to the materials I'm using, we can see I have a steel material, material number 2 for the beams, and concrete assigned to the columns. Similarly to the sections, we can right-click and see the properties of these 2 materials I'm using, which are the full materials that comes within S-Frame. Can click the render button off. Looking at the support conditions, my structure is fixed to the ground. Now we can move to the loads window. I defined 3 load cases: self-weight, dead load, and live load. Let's display the loads so you can better see the values. If we click here in the status bar, I have a dead load of minus 100 kilonewton per meter for the first 2 stories and 75 for the 3rd level. And the live load I have is 130 for the first 2 floors and for my roof I have -90. Now I can turn off these options. I also define a load combination for these load cases, and it can be checked if we go to Edit, Load Combinations. You can also access this information in the spreadsheet window. So I have one unitary load, unitary factor for these loads, all combined. You can see factor of 1 for self-weight, dead load, and live load. Now we can proceed with the next step. Start creating our construction stages. To do so, first we require to enable an option in the software preferences. If we go to Settings, Preferences, then I go to the Solver tab, and be sure to select this structure will be modeled and analyzed using a stage construction sequence. So I click here and I click OK. And if you haven't noticed, there's an additional tab at the bottom of the My Structure window, which is this one right here. Usually I work with the model organizer, but now I have a construction stages tab. If I click here, I can see there's a construction sequence command, and I can start defining my stages here. Start creating a stage by right-clicking and then select New Stage. You can give it a name if you like, but for the simplicity of the exercise, I will keep the original name. So I will create Stage 1, another new stage, and doing the same, I will right-click and select for New Stage for Stage 3. If you have created folders in the model organizer before, you'll see it's very similar. You need to define your stages, select the elements you want to add to the stage, and update the stage. I will start with stage number 1. Notice that I don't have any members added to this folder, and I need to select the members that are part of story 1. If you are experienced in S-Frame, you know there are different ways to select these elements. For this case, I will select the whole structure by clicking Select All. Then I change to a different view. In this case, I will select the left view, for example, and holding the Control key on your keyboard, making sure you have the selection tool on, you can start unselecting objects. Once I have my story 1, I can just go to stage 1, right click, update stage. Now every time I come here to this stage, I will see this selection. We'll do the same for the other 2 stages. Go to stage 2, select all, I hold Control with a click of the mouse to unselect the 3rd level. Go to stage 2, update stage. Finally, do the same for stage 3, select all. In this case, I just need my whole structure, so I just right click and update stage. Once ready and with the stages all set up, we need to go over one more step before analyzing this model. We need to start defining our preloads for each stage, and we can do so if we go to one stage and right click and go to the last option at the bottom, Construction Stage Status and Preloads. A new window will pop up, and first of all, I will set up the analysis options for all the load cases and load combinations, because I want to consider them. And remember, I'm working on stage 3 right now, and in the stage preload, I will select the first option, which is a load case. The preload I want to consider for this stage, and actually for all stages, are the same, the self-weight. And remember to click Update. Once you click Update, you will notice a change in the stage preload description, and this tells you that stage 3 will be analyzed for load cases and load combinations. Load case 1, which is our self-weight, will be used as the preload for stage 3. Okay, now I'm ready with stage 3 let's move to stage 2. Consider my analysis options, load cases and load combinations. My load case, self-weight, and update. And do the same for the first stage. Doesn't matter the order, as far as you select your preload and the analysis options you would like to consider. Users can also access further information by clicking the Help button while working on this window, and this will take you to the specific help topic, as you can see here, the construction stage status and preloads. Well, I'm going to click Close. Now we're ready to analyze our structure. I click the Analyze button. Right now I want to run a linear static analysis and click OK. It's going to ask me to save my changes. I click OK, and I notice the solver gave me a warning message. The message is GE003, number of global equations is 0, no free degree of freedoms, execution will be terminated. Okay, and I believe I know what the issue is. I noticed when I defined my stages, there were some nodes that were not selected and are part of that stage. Let's check this again. If we go to stage 3, we can see our whole structure selected. For stage 2, remember we only have these members selected, but I can see some nodes are not part of this selection. What I can do is I move back to the left view window and make sure to select those nodes and update my stage. Of course, there are no degree of freedoms if I don't have the nodes on that stage, on any stage. I just need to go, this time, having the selection tool. I'm going from left. I need to click on the screen. I'm going from left to right to select these nodes and update my stage. Now stage 1, do the same. Select these nodes that are missing and update the stage. Now let's try again running an analysis. This time it performed the analysis without any issues. You can scroll up to see the solver's operation, going with a linear static analysis through each stage. You can see it goes for the analysis through load case 1, which is the preload, 2 and 3 and the load combination, then go to stage 3, and finally, stage 2, and finally stage 3. If you ever receive any warning messages, the solver will suggest a document where you can see a better description of that particular message you are receiving. If you are unsure of that message, you can always send us an email and ask us for further information. And of course, we'll be glad to assist. Now let's go to the post-processing results. And I can start looking at the reactions, for example. If I go to the reactions tool, let's take a look only at the vertical reactions, the set force. And let's move to the dead load. Remember, this stage had the self-weight as the preload condition. These are just the results for stage 1, and you can also go and compare against stage 2 and stage 3. Same for the live load. For instance, in this case, it's taking into account the self-weight and the live load, and this is the reaction for the whole structure. We can check other results, such as actual forces. If we click here, we can ask to show the maximum forces. This will be for stage 3, the live load case. Compare in the similar way the differences between stages. If I go to stage 2, stage 1, to see the results that are of interest to us. Let's move to shear diagrams. We can check in Z and Y. Also the different load cases. And you can also check the load combination. These are the load cases. If you click the plus button here, you can see the load combinations. Select your load combination and go through each stage. Moment diagrams per stage. If you don't already know, more in detail information can be accessed per member if you double click or right click one of the members and access the properties. In this new window, you will see the force diagrams for member 58 for this example. Since we are in the moment, it goes to the moment diagram by default. You can see the maximum, minimum values, values in between per station. Right now we have 5 stations, but we can increase this number maybe by 90, so you can see more values. You also have the spreadsheet available, and the values you see here are automatically updated in the distance force fields. Of course, you can also modify this and select load cases. Basically, all the options you have here available, you can also see them here. If you need to take this data out, you can always export your data. We have different ways to do so. We also have the numerical results, where you can see all these values that we just saw in the graphical results window, but in a spreadsheet format. You can see all the reactions, the member forces per station. Remember, we have 5 stations, but if we like, we could decrease them to, let's say, 3 stations. Click here in the check mark to see less values. And you have all the forces available here. We will proceed now with the design code check for this structure using steel and the integrated concrete design. As you already know, this is a mixed concrete steel structure where the columns are made of concrete and beams made of steel. And we will perform the code check for the 3 stages for comparison purposes. Now if I go back to my model, after checking the results, we're ready to go into steel. If I go here, click this command, build steel design model, I go into the steel interface. Starting with the code input window, you can check the different parameters before proceeding with your code check. For this case, I will keep the defaults, but you have more information about each of these tools in the help system, or you can also attend the steel training, P201, Introduction to Steel, and P203, Advanced Steel training courses. I would suggest to keep an eye on our website for these upcoming events. Of course, if you have an active E&S agreement, you are more than welcome to register at no extra cost. Moving on, I just want to make sure I'm using the design code of interest. In this case, I would like to use the arrow codes. So if I go to options, design code, I can see I have my design code selected. Now I'm ready to perform a code check for my first stage, number 1. Here you can see the selected objects for my selected beams for the first story. I click code check. You can select all the load cases and combinations, but to keep things simple, I will select just my load combination number 1 and click OK. And now I have access to the code results window, where you can see the different utilization ratios. Before checking on the code check results, I just want to perform the code check for the other 2 stages. So I go back to my code input window. Similarly to stage 1, I will select stage 2, and then ready to go code check for the same load combination, click OK. Now I have my stage 2 code check ready. Finally, for stage 3, same process, select stage 3. You can see every beam from the different story for the whole building is selected. Go to code check for the same load combination number 1 and click OK. Now that I have all my steel beams code checked for my different stages, I can start comparing my results. Let's focus our attention on one beam only. Let's see this beam. If I right click and go to code details, I can see this is member number 2. And these are the code checked results with showing the different clauses from the error code. Before taking a closer look at this, I just want to go back, so I close this window and start with stage 1. Let's hide the unselected objects so I can have a better view. I can see my code utilization ratio is 0.71, showing color green. For stage 2, this decreased to 0.67 and is showing color blue. For stage 3, finally, I have 0.68. Now you may be wondering why is the difference. So we can take a closer look. If we right click on the member, and this is one of the advantages of STIL, you can still see the forces either in the code details or the force diagrams, which come from the S-frame analysis. So I click the force diagrams, and let's focus our attention on the forces, especially the action. You can see I have a positive force, meaning that this member is in tension. Also, take a look at the shear and bending diagrams. I click OK. Now I go back to stage 2. Take a look at the force diagrams for this same beam for stage 2. My tension force is a bit bigger, and the shear and bending moments are basically the same. Click OK. Finally, stage 1. If I right click on the same member, just considering imagine the first story just being isolated, go to force diagrams. Now I can see there's a difference here. I have a negative axial force of minus 83, meaning this member is in compression. And that's why is the difference in the utilization ratios. While the other two stages, this same beam is being subjected to tension. And the shear and bending moments are quite similar. So I click OK, and now I can have a better understanding why the differences between these utilization ratios. In the same way, you can access, if you right click, the code details for that particular beam for the load combination I have, which is subjected to bending and tension. You could print this report into a PDF for later comparison. You still have the force diagrams here. Just to double check stage 1, if I go to code details, you can actually see this is being subjected to bending and compression. Moving on, we'll go back to S-frame by clicking this icon here, Build Analysis Model. Once in S-frame, and remember we already have our structure, the different stages analyzed, we can proceed with the concrete design for the columns. For this, if you have ICD or Integrated Concrete Design, you will see this icon here. You will be able to go into the ICD. So I click this icon, and this is the ICD interface. Pretty similar to STIL, but for concrete design. you have the similar windows: code input, code results, design input, design results. First of all, I select my stage number 1, check on the concrete parameters that I would like to use. In this case, I just keep the defaults, but you can find further information about these parameters in the help system. So I will proceed with my stage 1, which are the columns at the first level, and go and perform a code check for the first load combination, similar to what we did with STL. Here are the utilization ratios. You notice you go directly to the code results window. Then, similar to our previous example, I go back to the code input window, select my stage 2, and then run the code check for the same load combination. And after this, and you guessed it, I will proceed in a similar way for stage 3. So I go back, select stage 3, let me zoom out a little, and then run a code check. Once ready, we can start comparing our utilization ratios for the different stages in a similar way we did with STL. Just to show you an example, if I go to stage 1, I would like to access the results for this column, which are one of the in the vertices. If I right click, go to code details, I will be able to see the different force diagrams that applies to my model, that applies to my member. To see the different classes, you just need to click this link here, which will launch S-Concrete to see the different code checks. So I just click OK, and you will see S-Concrete in a new window. This is the S-Concrete Visual Editor. You can check the utilization ratios here. You can increase this, the size of the window. So this is a rectangular column. You can access the results if you go to the results report. And in this window you will see a detailed report of this particular concrete section. You have hyperlinks here if you would like to check the actual versus moment utilization ratios, or the shear and torsion. And at the bottom you have a list of messages which gives you some hints of different warnings you may have while doing the code check, and showing the clause that you should check according to the error code in this example. So I'm going to click close. You can close here to go back into the ICD report. Now we will go over the second modality available when working with stage construction: multi-scenario analysis and design. And why use this multi-scenario analysis and design? It enables the engineer to compare the performance for two different scenarios for the same design. They can compare the structural analysis results and also compare the code check results when performing a steel or concrete design according to the major international standards. And here is the example we're going to show: a warehouse that is already built with two design scenarios. You will notice that there are some differences between these two pictures. The one on the left doesn't have any braces, the beams on the roof are hollow sections, and columns are pinned to the ground. The one on the right is fixed, it has some bracing added, and the beams on the roof are I-shaped sections. And we will compare the results of each stage. Since the structures are made of steel, we will also compare the code check results for each design scenario using the integrated steel design. But please bear in mind that you can also proceed with a code check for concrete elements by using integrated concrete design, also called ICD. And here's the model we're going to use to follow this example. You may have noticed that the stage construction feature is active. And the way to confirm is that you guys can see this construction stage tab at the bottom. So if I click on it, I see I've defined two stages. I call them Design Scenario 1 and Design Scenario 2. And let's check some of the differences between these two design scenarios. For number 1, I see immediately my braces are unselected because they do not belong to this stage folder. You can click here to hide unselected objects to see the unselected braces. By looking at the section properties, you can see the sections I'm using, and you can either go within the tool, or you can render your model to see the sections I'm using for this exercise. The material properties, I'm using a steel material I created. For the supports, all my columns are pinned to the ground, so rotation is allowed on each one of them in the 3 degrees of freedom, X, Y, and Z. Moving on to the loads window, I can see I defined 5 load cases. So if I display my loads in the status bar by clicking on, I can see my self-weight, the roof dead load, snow load, wind load, and some crane loads. I also can check my load combinations I define. If I go to Edit, Load Combinations, I have 2 load combinations. For the first one, I have load combination 1, including load case 1 and 2, which are my self-weight and roof dead load, with these factors 1.4 and 1.7. And for load combination number 2, I have load case 3, snow load, and load case 4, wind load. And you can see them here. You can also access this information in the spreadsheet for the load combinations. Now let's see the properties for design scenario number 2. So I go back to the geometry window. In this case, I'm going to select my design scenario number 2. Immediately you can see I have fixed supports for this case, so the supports are different from the first design scenario. Checking the properties, if I render my model, you guys can see, similar to what I show in the slides, that the beams on the roof are different. These are I-shaped sections. The braces, double angle, are added, and basically these are the main differences. Also for material, if I stop rendering my model, this is same material number 1. I go to the loads window and check I have the same load cases, same load combinations. If I go through each load case, starting from the self-weight, going to the roof dead load, I can confirm I have exactly the same loads applied. Same as the load combinations. If I go to Edit Load Combinations, I have the same load combinations as before. Basically, the goal here is to compare the results between these two design scenarios. And you will notice the load path will be different due to the new elements included support, sections, member type, among others. Oh, I forgot to mention that these braces are classified as truss type elements. You can see it in the geometry window. Sorry guys, I missed to mention this part. Here you can see it. I have my beam type elements and my truss elements as my braces. Now we're ready to analyze this model, run a linear static analysis for stage construction. But we need to check one more thing. Before analyzing your model, if I go to Analyze, please make sure to have this box checked. Exclude preload for all stages, since we don't want to account for any preloads in the design scenarios we have created. I click OK to run my analysis. For the two stages, the solver is giving me a clean solution. So if I press Enter or any other key on your keyboard to access the results and start my comparison. Let me just stop displaying the member loads and the joint loads. For this exercise, I'm going to focus on load combination 1 results to make things easier. I just go to my view load combinations, load combination number 1. Let's start by checking some of the reactions. Remember, I'm in design scenario number 1. I displayed the reaction force in Z. You can see the values. I have a shear force in Z about 580 kilonewtons. For design scenario 2, I have 630, nearly 630 kilonewtons. And you guys can see the different values when the braces are added, also taking into consideration the supports I have, the type of supports. Remember, for design scenario 2, if I display my supports, this is fixed, and design scenario 1 is pinned to the ground. I can also check on the deflections. If I display the Z displacements. For design scenario 1, I have a maximum of nearly 65 millimeters. For design scenario 2, the maximum will be 37, almost 38. As you know, of course, the roof beams have more stiffness in this case compared to design scenario 1, including the bracing I have added. In the same way, we can compare the force results, and you can do it graphically, as we are doing right now, or numerically using the numerical results window. If I go to numerical results, let me expand this a bit so you guys can better see, and select the member force spreadsheet. One thing I can do, having these results printed, if I would like to have these results at hand, maybe if you are a visual person, this may be the best way to compare the results. Right now I'm looking at the results for load combination number 1. You can also check for to see all the load combinations 1 and 2. Right now I have 5 stations, but you could decrease this or increase it more. You just change it and click the check mark button. Now I have 3, and this will be one edge, the other edge, and in the middle for combination 1 and combination 2. And you can also bring this, you could also export this into a Word document. One way to do it is if I add this to a document first. You can give it any name you like. In this case I will keep report number 1. I click OK. This new window will show. In this case I just want the results for load combination 1 to make things easier. And I would like to see the member forces, and I click OK. So this was added to my list for documents to be exported to Word. But I also want to select the design scenario number 2 and compare this against the previous list I created. So if I add this to another document, to the same document, I'm going to call it report number 2, just as it is. Same thing, I just want load combination number 1 results, the member forces. You could also bring other data if you would like to compare. For this case, we're just focusing on the force results. And once you're ready and you have added all the documents, you can also add the different images from the graphical results window as well to this Word document. I just need to click Export to Word. You can select the order here, and once you're ready, you just need to click the Word button. I'm going to save this multi-scenario example using the same name. I save it, and S-Frame will create this report for you so you can compare the results. Now let's proceed with the steel code check using STIL for the multi-scenario analysis and design method. As you can see from the images, the sections have different utilization ratios according to the load demands of each scenario. So let's get back to our model. With the model already analyzed, I can proceed and open STIL. But remember that you can do the same with integrated concrete design for the design of concrete sections. So I go run STIL, and it will open STIL, as you can see here, with this similar interface to S-Frame. I switch to the design scenario number 1, and you can also update your code check parameters in the code input window, such as steel grades, connection types, some negligible forces that you would like to account for. You can do here. But we will keep the default values, and do not forget to double check the design code you want to use. If you go to Options, Design Code, and I will keep this design code I have, the British standards. You click OK. Remember to select your whole structure. Select all. And run a code check. I will run the code check for load combinations 1 and 2, and I click OK. Immediately I see the utilization ratios in the code results window for this design scenario number 1. Before checking on any of the results, let's go back to the code input window and select design scenario number 2. Similar to design scenario number 1, you can review your steel parameters before running the code check. And once ready, you go to code check, and I'm going to run the same load combinations. Click OK. Now that I have both code check results for both the scenarios, I can start my comparison. I will focus my attention on the roof beams. If you guys remember, these are I-shaped type of sections for the design scenario number 2, and hollow sections for design scenario number 1. I can toggle this option off to render my model. You guys can see I have a 0.4 of utilization ratio for the design scenario number 1, and 0.7, almost 0.8 for design scenario number 2. You can select one of your roof sections, for example this one, and access the code details for further information about the different clauses for each check. You can either press the page down button on your keyboard, or you can go to View, Previous Page, Next Page. This is the I-shaped section I talked to you guys about. We saw it in the first part of the exercise. And of course you can also print these results for later comparison against the other design scenario. I can click close here, and I'll focus my attention on design scenario number 1 on the same beam. If I right click, go to code details, I can access the different clauses for the same results I'm looking to compare. And also I can print this into a PDF to show to a colleague or a client later. Basically, if I close here, basically I'm evaluating which model performs better. Remember that this is just an example and is not considered a fair comparison since the supports are different, but maybe this could be what you're looking to compare. I'm just showing the parameters you can change for comparison. In other words, the different options you can have. And finally, the reporting. With integrated steel design or ICD, you can generate professional looking reports with detailed results. You'll also have available the clause references according to the design code you are using. As you notice from the example we followed, we can generate these reports. In this case, these are the key code check results. You can print the different pages for the different load combinations for each member. You also have a summary of governing load cases. You can also view quantities, among other results. So in this presentation, we started with stage construction, an introduction to the exercise we follow. Then we perform steel and concrete code check. Then we jump to the other modality, the multi-scenario analysis and design. We perform a steel code check for these different design scenarios to compare the results and the reporting. To sum things up, when working with stage construction, you can perform this type of analysis for the assessment of your projects. We discussed that you are able to compare similar but different models in one S-frame interface with multi-scenario analysis and design. You can run a full steel or concrete code check and design in one step, and showed how to generate detailed reports to share with the colleagues or client.